Hello and welcome to the Siemens Aerospace and Defense webinar focused on assembly planning for the factory of the future. My name is Henri Thevenot. I am currently the industry strategy leader for our Aerospace and Defense Federal and Marine division at Siemens Digital Industries Software. The overall approach for digital transformation is through the digital enterprise represented here, where we allow you to create a digital twin of both the product and the production process and leverage it to support production, but also allowing you to analyze and gain insights from the product and the process for continuous improvement. For aerospace and defense, we have 7 digital threads with prescriptive business processes to help you guide through your digital transformation. Out of those 7 digital threads, we will be focusing today on the smart manufacturing one. And mostly we will be spending time on the front end and the design phase, around preliminary production planning and production process development. Traditionally, engineering and manufacturing planning happens almost sequentially. Now, they happen concurrently during this phase, and you are shifting your manufacturing planning to the left, where you can quickly explore and optimize alternative manufacturing methods, cost, and feasibility. In the first step, preliminary production planning, this is where you mitigate manufacturing risk in the conceptual phase by identifying and addressing issues early in collaboration with engineering. At the end of this step, you have an idea of the overall manufacturing breakdown, which is the high-level manufacturing bill of material, as well as the high-level process breakdown, the bill of process. You also have an idea of the facility and the machines you'll need and the sourcing strategy. As we move into the second step, production process development. As the design matures, you now detail out the process, you evaluate it, and you update it virtually. Once you're satisfied with the manufacturing plan, you can leverage that plan to support production through virtual commissioning, but also robust integrations to downstream execution systems used to support production. At the end, you have a fully validated and detailed bill of process containing all the information you need to build the product. That includes operations tools, equipment skills, work area, work instructions, data to collect, etc. The digital twin of the production process contains several elements. First, you are able to use the engineering data definition, the engineering bill of materials alongside with the 3D models in order to create a manufacturing representation of it, or a manufacturing bill of material. Second aspect, you are able to use engineering requirements on the 3D models to define inspections, which then are being used to define inspection operations. The third element is the bill of equipment, which contains the plant structure, the tools, the equipment that you have, alongside with the 3D models for those. All of these 3 elements feed into the bill of process, which will have all you need to support production. The order of operations, the parts you need, the tools you need, where you're going to build it, work instructions, supporting elements, including 3D models, etc. All this information is constantly refined by simulating it and validating it through extensive simulations, which you have seen in previous webinars. Once all that information is ready to go and you have validated, you are able to then leverage that information to support the downstream systems. All this information is authored and maintained and developed in EasyPlan. That's what you're seeing here. For an example, you're seeing on the left-hand side the bill of equipment first, which is where you're going to be building with a hierarchy of assets. You see the manufacturing bill of materials, which is what you're going to build. All this information then get into the bill of process, what you see on the left-hand side, which is all the operations you need in order to, in that case, build this assembly. But it's not just a sequence of operations, it's all the rich information around it. It could be textual work instructions. It's making sure you call out for the right parts directly in the systems. It's making sure you can have 3D representations as well. It's making sure you can call out the right attachments within the work instructions if it's applicable. All of this is created and maintained in EasyPlan and can also be used to support simulations, again, as you've seen in previous seminars. Last thing I want to share is how we take that information and then use for downstream execution. As you can see here, a different bill of process, and we're going to use our out-of-the-box integration to get that information into ERP, in that case SAP, but also in our MES system, Op Center, so that when type comes to support the shop floor execution, all the same information that was authored and validated is now available at the fingertips of the operator to support day-to-day operation. As a summary, with that connected digital twin that allow to develop the plan, tied to engineering data, tied to extensive simulation tools to help identify issues very early and address them virtually, you are able to minimize risk before the product gets put together, and you're able to increase your first time delivery of that information on the shop floor overall to increase the efficiency and optimize production. Thanks for listening and looking forward to seeing you again on a future webinar.